Hello guys, this video is about differentiation and the focus will be on function of a function or composite rule or chain rule. To be able to identify questions under function of a function or composite rule or chain rule, you will be having functions, original functions carrying other functions. For instance, if y is equal to sine x, if y equal to sine x, it's supposed to be an original function, but if we have y equal to sine 2x, this is function of a function. That is, another function has already been added to the original function. Or for instance, if I have sine into 2x squared plus 7x plus 5 is a function of function. Ordinarily we should have ln x. Okay, ln is called ln, or the Napierian logarithm, or the log to base e of x. But now this is supposed to be the original function, but if I have ln 2x is function of a function, ln of sine x is function of a function. So, or if I have exponential x, that's supposed to be the original function, but then if you now have exponential sine x, that's function of a function. So this is how to identify function of a function. Or in another sense, if y equal to 2x squared plus 7x, this is a function, but it will become function of a function if I have 2x squared plus 7x all squared. So we now have another version of it, so it's now function of a function. So these are some of the few ways to identify function of a function. Let's say we have a function y, the derivative of y, which is also called the dy dx, okay, will be on is on the other side. So let's say my y is ax raised to power n, e.g. if I have y which is equal to 2x squared minus 7x plus 5, then the dy dx will be equal to the old power, which is n, will multiply the function, that is I will have n a x, then I should have a new power since I have already used the old power. The new power is that I will subtract 1 from the old power. So what I will have for this will be 4x raised to power 2 minus 1, which is 1. Okay, then for minus 7x, I should have something of this nature, minus into 1 times 7. Okay, then x raised to power, the initial power is 1, so I need to subtract 1 from the old power. Okay, so this is supposed to be 2 minus 1 right here. So for a constant like 5, I can have it as 5 raised to power, a constant is like having 5x raised to power 0, because x raised to power 0 is 1. Okay, so if I do the differentiation, that's like 5 times 0, okay, or 0 times 5. So I can have 5 times 0, then x raised to power 0 minus 1. Okay, but I know that 0 times 5 is 0 and 0 times x is 0. So anytime you differentiate a constant, you will always have it to be 0. Okay, so I'll have this, and then the first one will be 4x raised to power 2 minus 1, which is 1. Then I should have minus 7 times 1 is 7, x is to power 0, anything raised to power 0 is 1. So I have 4x minus 7 into 1 plus 0, which is the same thing as 4x minus 7. Alright, so anytime I have a function, I just need to multiply the power, old power, by that particular function, and then I subtract 1 from the old power to give us a new power. Okay, so it is the same thing as if I have something of this nature. Let's say y is equal to 2x plus 1 squared. If y is equal to 2x plus 1 squared, I can say I can expand the bracket so that I will have 4x squared, okay, plus 4x plus 1. If you expand this bracket, this is what you will have. So I can say dy dx is equal to 2 times 4, that's 8. X is to power what? 2 minus 1, which is 1. Okay, so make sure you are doing that correctly. Multiply the power by the function, just like in ax is to power n. Multiply the whole power, that's nax. Then to get your new power, then you subtract 1 from it. It works. So 4x, anytime you differentiate something of that nature, you are going to have 4, because it will be 4x is to power 1, which is the same thing as 1 times 4. X is to power 1 minus 1, and anything raised to power 0 is 1. That's 4 times 1, which is 4. Okay, so if I differentiate the constant, I will have 0, isn't it? So answer is 8x plus 4. But let's say I don't want to expand the bracket, because sometimes I may have functions that are complex that I will not be able to expand the bracket, just as this. Okay, let's say I cannot expand the bracket. How will I do it? Let's do it for this particular example. Okay, so what I will do is that I will differentiate what I have inside this place, which is 2. I'll write it out, dot. Okay, then I'll do what I'm supposed to do, which is the normal differentiation for functions that has to do with brackets. Okay, if it has to do with brackets like this, if it has to do with bracket as in this and this, then what I have to do is to say that 2 multiplied by that bracket, then 2 minus 1. So I got these two from the power of the bracket. Okay, just like we used to do when we have ax is to power n right here. So that's just it. So what am I supposed to have in the bracket? 2x plus 1. So finally 2 dot 2 is 4. It's the same thing as 2 times 2. Then my bracket is 2x plus 1. Alright, so that's it. You can see 4 into 2x plus 1 is the same thing as 8x plus 1 plus 4 rather. Okay, which is what we got the other time. Now let's say I don't want to expand this one as well. What do? I differentiate what I have inside of the bracket. So dy dx, so this is not supposed to be y, this is supposed to be dy dx. So dy dx will be equal to, I will differentiate 1 minus x over 3. If I differentiate 1, that's 0. If I differentiate minus 1 over minus x over 3, that's supposed to be minus 1 over 3. So if I dot it, then I'll differentiate the bracket. Differentiating the bracket is 99, the bracket, then 99 minus 1 as the power. So 3 dividing 99, that will be equals to minus 33 into 98. Okay, so what am I supposed to have in the bracket? 1 minus x over 3. So that's the way it is. That's the shortest way to find it. And we can also make use of the formula, the function of function formula. Okay, so let's say I want to solve this one that has to do with y equal to open bracket 1 minus x over 3 close the bracket raised to power 99. I can use the function of function formula, and the function of function formula is that dy dx will be equal to dy du multiplied by du dx. So it's very correct to seem like du can cancel out du, so that dy dx will be equal to dy dx. That means every time I have a function like that question, 1 plus x over 3 raised to power 99, I will always have to say let u be what is inside the bracket. If u is what I have in the bracket, then I can find my du dx. Okay, I can find the du dx, so that I would have achieved one of the parameters of the formula. Du dx is that if I differentiate 1, that will be 0. If I differentiate x over, there is a mistake now, because I'm not supposed to have positive right here. From the question we had negative, so let me just put that here. So it's supposed to be negative. Okay, negative. Now let's continue. So du dx will be equal to, okay, So I'm supposed to have, if I differentiate minus x over 3, I'm supposed to have minus right here. If I differentiate x over 3, x differentiating itself, that will be 1, then over 3. So I don't want you to get it wrong. It is just like differentiating 2x. If you differentiate 2x, the power of 1 will multiply it to give you 1 times 2 raised to power x raised to power 1 minus 1. Okay, which is the same thing as 2. So the same thing with minus x over 3. It has a power of 1. So and that one is multiplying minus 1 over 3. Then x is raising the power of 1. Then is subtracting 1 from it. Okay, that's 1 minus 1. And of course 1 minus 1 is 0. So I'll have 1 times minus 1 over 3, which is equal to minus 1 over 3. So I'll have something of that nature. So minus 1, so 0 minus 1 over 3 is minus 1 over 3. Okay, so let's now find if you say that y is now u raised to power 99, because you have substituted 1 minus x over 3 as u, then it means that y is now equal to u raised to power 99. So we can find our dy du, so that we can know the second parameter of the formula. Dy du will now be 99 u raised to power 98. Okay, so if that is the case, we can now find dy dx, which is equal to dy du is 99 u raised to power 98 multiplied by du dx is minus 1 over 3. So 99 divided by 3 is supposed to be 33, but because of the minus, I should have minus 33 and then u raised to power 99, so that I will have minus 33. U is what I have in the bracket. I substituted it as minus 1 over 3, so raised to power 99. So this is another method of doing it by using the function of function formula. Okay, so subsequently in this video I will avoid using this particular formula. So I would rather go by differentiating what is inside the bracket, dot it, and do some other normal differentiation. But I purposely use this formula right here so that you will understand that the formula also abides by what we are doing in this video. No, that's supposed to be 98, because we had 99 u raised to power 98, so this is supposed to be 98. So we're supposed to have 98 right here. Okay, so that this will be 98, and as a result the final answer too will be 98. So just like the one we solved initially, so we'll have it the same. So the implication is that whenever we have a function, let's say f of x, okay, if I differentiate this f of x, let's say f of x has a power raised to power n, just like this question, what is inside the bracket is referred to as f of x, is a function of x, and then it has a power n, like 99. So the derivative of this kind of function, let me have it on the standard table. So we have a function f of x and it's carrying a power n. If I differentiate this particular function, okay, let me get rid of this space, I'll have something of this nature. The first thing I'll have is the derivative of the function first. So this is the sign for the derivative, f prime. You put a sign. So f prime of x is the derivative. Then I'll have a dot. Then I'll have the normal differentiation according to the first principle that we have on the standard differential table. So I'll have n open bracket the function, okay, then raised to power n minus 1. So that's what we'll have, and that is what, so that was what we did when we had the question y equal to 1 minus x over 3 raised to power 99. We differentiated what is inside the bracket, which is the f of x, and we got minus 1 over 3. Then we put a dot, just like we had this dot. Then if we do the normal differentiation, that will be 99 then open bracket, close it, then 99 minus 1. Okay, so what are we supposed to have in the bracket? 1 minus x over 3, which is the function. So eventually we can simplify this so that 3 cancels out. 3 divides 99 to give us 33, and then 99 minus 1 is 98. So that's how it is. Now let's solve one more problem concerning this. So if y is equal to, let's say, 3x squared minus 5 raised to power 5. So what I will do is differentiate what is inside the bracket so that I will have 6x. Okay, then I'll put a dot, then I'll do the normal differentiation as in the first principle. So I'll have 5 open bracket, close it, then 5 minus 1. So what am I supposed to have in the bracket? 3x squared minus 5. Alright, so 6 times 5, that's supposed to be 30x into 3x squared minus 5 raised to power 4. So that's supposed to be the right answer. Now let's say if I have a function like sine x, if I differentiate sine x, I'll have cos x. Okay, if I differentiate cos x, I will have minus sine x. Alright, so if I differentiate tan x, I'll have sec squared x. Okay, so let's say I have a function, for instance, let's say y is equal to the square of sine x. If I want to differentiate something of this nature, the first thing I will do is to rewrite it and make it look like this: sine x all raised to power 2, because the truth is that the square of sine x is the same thing as sine x all raised to power 2, but it is not the same thing as sine x raised to power 2. Okay. So now it looks like when we had this particular question, now it looks like this because of the particular bracket. So what do I need to do? I need to differentiate what I have inside the bracket. If I differentiate sine, I will have it as cos x, so I need to put dots. So I'll do the normal differentiation of what I'm supposed to have inside the bracket, which is 2, then sine x, then 2 minus 1. So I will have 2 cos x into sine x raised to power 1. Okay, so it is the same thing as 2 cos x then sine 1x, but you don't need to write sine raised to power 1x. You can just write it like this. All right, so this will be the right answer. Okay, now let's say we have something of this nature. Now let's say you have y equal to the square root of 3x squared minus sine x. Okay, okay. So the first thing we need to do is rewrite it and make it look like this: 3x squared minus sine x raised to power 1 over 2, because the root of any number, so according to the law of indices, the root of a is a raised to power 1 over 2. So that's the same thing I have. So what do I need to do? I differentiate what is inside the bracket. If I do that, I should have 6x then minus cos x, because if I differentiate sine, I should have cos. So I just need to put a dot. I'm using a bracket because I have two functions separated by minus. So then I do the normal differentiation. That means half should come down, then I should have a bracket, then I should have half minus 1. Okay, so the things in the bracket, we have 3x squared minus sine x. Alright, so I'll have 6x minus cos x over 2, just because of this particular bracket. Then I'll have 3x squared minus sine x. Half minus 1 is negative half, which means, because a raised to power minus 1 over 2 is the same thing as 1 over a raised to power 1 over 2, which is the same thing as 1 over root a. That means I'll have something of this nature: 6x minus cos x over 2 into root 3x squared minus sine x. So that's the answer. Okay, let's move on. If I differentiate exponential x, I will have exponential x. Okay. Also, if I differentiate sec x, okay, I will have sec x tan x. If I differentiate cot x, I'll have minus cosec square x, okay, and several others. Now let's solve some other examples. So let's say I have y which is equal to a cos cos 2x squared plus 7x minus 5. So the first thing we need to do, this is a function of a function, simply because a function is carrying another function. That's what this video is all about. Okay, if you look at it, cos is supposed to be an ordinary function like cos x, but when we now have cos 2x is a function of function, or when we have cos into bracket several things, that's function of a function. So the first thing I need to do is to differentiate the function which is inside it. Okay, and that's what I have been doing. So if I differentiate 2x squared plus 7x minus 5, I'll have 4x plus 7. So I just need to put the dot. The next thing I will do is, we don't have the bracket differentiation here as in this number one. No, what we have is cos. Okay, so I'll make use of the derivative of cos. So if I differentiate cos now, I should have minus sine. Okay, minus sine, and of course it can't be empty, so I just need to fill it with what it has. Okay, which is 2x squared plus 7x minus 5, and we have a constant here which is a. The constant cannot be affected. It is just like when you differentiated 2x. Okay, what you differentiated, if you differentiate 2x now, your dy dx will be equal to 2, and the reason is because you differentiated x to give you 1. So it is with respect to x, it has nothing to do with the constant. But if we had only the constant standing alone, let's say y equals to 2, our dy dx will be equal to 0, because it is only considering a constant. It does not have the variable, and remember, the derivative of a constant k is equal to 0. Okay, I hope you understand this. So this is supposed to be the right answer. Okay, but let's say we had these two, y equal to sine into 2 cos x. Okay, let's consider this. So what I will do, I will differentiate the function inside the function, which is what, which will now become minus 2 sine x. Then I'll put a dot. Okay, I'll differentiate sine, which will give me cos, but cos cannot be empty. Okay, it should always have something. Okay, so but what I'll fill it with is what it came with, is what the question asked from the beginning. So this is the right answer. So that's the way it is. The same way if I had y to be equal to tan 5x. So what I need to do is to differentiate 5x so that I will have 5. Then I need to put dots. I just need to differentiate tan, which will give me sec squared. But sec squared cannot be empty. I can't just write sec squared x because the question did not come with sec squared x. Okay, the question has 5x. Alright, so that's what we'll apply. Okay, so that's the dy dx. Okay, so let's say I have another function, y equal to sec 7x minus 5. The dy dx will be that you differentiate what is inside the bracket, which will be 7 dot. If you differentiate sec, that will be sec that particular thing, then tan that particular thing. Okay, just like when we differentiated sec x right here, we had sec x tan x. So if I don't have x here, I won't have x here, and I won't have x here. All right, so what I'm supposed to have here is 7x minus 5, 7x minus 5. So let's say we have a particular function as this exponential 2x. Let's say exponential 2x. Now remember, if I differentiate exponential x, I should have exponential x. So if I have exponential 2x, the dy dx of exponential 2x will be that I will differentiate this function and that will be 2, then I dot it. So if I differentiate exponential, it usually repeats itself. And of course, it can't be empty. I need to refill it with the original question, just like that of sine cos. So I'll just have 2x, and that's the answer. Okay, so let's say I have something of this nature. Y equal to exponential 5x squared plus 7x minus 2. So what I just need to do is that my dy dx will be equal to the derivative of what I have at the top, and that's supposed to be 10x plus 7. I need to use a bracket since we have two terms. Then if I differentiate exponential, it will repeat itself. So I just need to fill it with what it has, 5x squared plus 7x minus 2. So I can write a general formula for it, that if I have exponential function of x, okay, the derivative will be that I will have f prime of x, then exponential that original function. So that's the rule for that. Now for that of sine any function of x, okay, what it will be is that I will differentiate that function first, then I will differentiate sine, that will be cos, then I'll fill it with the original function again. So that's it, that's the formula. So what if we have cos, any of them, so cos function of x, you can apply a bracket right here so that it will be okay. You can apply a bracket right here. So I'll have something of this nature. I need to differentiate the function inside that, and we used to represent the derivative of that function with f prime. If I differentiate cos, I should have minus sine. Okay, then I need to repeat the same function again. Alright, so that's the way it is. Even if you have sec x, even if you have cot, okay, let's say I have cot of a function of x. The cot of a function of x, I need to differentiate the function first so that I will have f prime of x. Then remember, if I differentiate cot, I should have minus cosec squared, cosec squared of that function, which is f of x. So that is it about function of a function. Okay, now let's talk about ln, which is also called Napierian logarithm, or log to base e of x. Okay, now if I differentiate ln, I should have 1 over x. Now, so let's say I have the ln of 2x. Very simple. If y is equal to ln 2x, my dy dx will be equal to, I need to differentiate this first so that I will have 2, then I dot it. The normal differentiation of ln is supposed to be 1 over that function, just like I have here. If I differentiate ln x, I should have 1 over x. So the normal differentiation of ln is 1 upon the original function. That's supposed to be 2x. Okay, so eventually I should have 2 over 2x. So it means that if y is equal to the ln of a function of x, the derivative, which is dy dx, will be equal to f prime of x dot 1 over f of x. Okay, so which can also be written as f prime of x upon f of x. Is as simple as that. So let's say I have the ln of sine 2x, the ln of sine 2x. That means I need to differentiate this first. And of course, if you remember, if I want to differentiate, if y is equal to sine 2x, so we need to differentiate 2 first. Don't make the mistake of saying that the derivative of sine 2x is equal to cos 2x. Okay, you differentiate 2x first, then you have 2 dots. Okay, you differentiate sine, that is cos, then you repeat it 2x. Okay, so I should have 2 cos 2x upon the original function, which is sine 2x. Alright, so that's all, but I can still simplify it, because cos 2x upon sine 2x, that's supposed to be cot 2x, since cos over sine is cot. So that's just a simplification anyways. But now let's say I have another function, the ln of 2x squared plus 7x minus 5. Okay, we apply a bracket just to make it look moderate. So I should have 4x plus 7, that's the derivative of what I have inside the function, upon 2x squared plus 7x minus 5, and that's the right answer for that. Okay, so let's say y is equal to sine into 2 cos x, and the question says that you find the dy dx, or the derivative at x equal to pi over 4. So I should have something of this nature. The dy dx, we need to first find the dy dx. Okay, the dy dx will be equal to the derivative of this. Okay, and that will be minus 2 sine x dot, I will differentiate sine, that will give me cos. Then I need to open the bracket and refill it with what I have originally. So but the question says that we should do it at pi over 4. That means after I have differentiated, any place that I can still find my x, I should replace it with pi over 4. Okay, cos into 2 cos pi over 4. So this is supposed to be the right answer. So if I can find a way to press this directly on the calculator, I should have the right answer. So you need to note when pressing this on your calculator that whenever we are dealing with trigonometric ratios like sine and cos, pi is always equal to 180 degrees. Okay, so but if you insist on using pi as pi, then you need to convert your calculator from degree to radian. Okay, by making use of the shift menu or shift setup, depending on your calculator. You just need to know how to convert your calculator from degree to radian. So if you do that correctly, the sine of pi over 4, that should be equal to root 2 over 2, or you may just use your calculator in degree. If you don't know how to convert it, just make sure you change your pi to 180 degrees and it will be correct. So I should have, so the cos of pi over 4, that should be equal to, that's equal to root 2 over 2 as well. So I have root 2 upon 2, so 2 can actually cancel out 2, so that I'll have something of this nature, negative root 2 then cos root 2. So this is supposed to be the right answer. Okay, but you can still simplify this further anyways if you want to, but this is one of the options for this particular question. Okay, so let's say I have a function, for instance, a raised to power x. Let's say y is equal to 2 raised to power x, and you want to find the dy dx, or the derivative of this particular function. The derivative of a raised to power x is a raised to power x ln a. Okay, so I should have 2 raised to power x then ln 2 as the final answer. But let's say I have y equal to 3 raised to power 2x. So it will mean that I need to rewrite it and make it 3 raised to power 2 into x, since they are the same. And of course 3 raised to power 2 is the same thing as 3 times 3, which is 9 raised to power x. That means I want to differentiate 9 raised to power x, and the derivative of 9 raised to power x will be equal to 9 raised to power x ln 9. Alright, when I have f of x, or a function of x, it means any relation that consists of x. It can be 2x squared, it can be sine x, it can be anything, it can be x. So that's what I mean by the function of x that you can find around throughout the video. So let's say we have some inverse trigonometric ratios. For instance, if we have the arcsine of x, or generally if we have the arcsine of a function of x, it will be equal to, first of all, the derivative of that function of x upon the root of 1 minus that particular function, then we'll have it squared. So let's say we have arc sine of x. Arc sine of x will be 1 over square root of 1 minus x squared, simply because the derivative of x is 1. Okay, and this is the original function. So if I had arc sine of 2x or any other function, so what I will have at the numerator should be the derivative of 2x, which is 2, upon square root of 1 minus 2x squared, which is the same thing as 2 over square root of 1 minus 4x squared. So what if I had the arc sine of cos? Okay, no, I mean the arc cos of a particular function. Arc cos of a particular function, that will be the derivative of the function upon the square root of 1 minus the square of that function. It looks like that of the sign. The difference is that we have a negative sign. That's just the difference. Okay, so let's say I have that of arctan as well. Arctan of a particular function. So I'm supposed to have the derivative of the function, that's f prime of x, upon 1 plus the square of that function, and that's it. Okay, so let's say I have the arctan of 2x, so the answer is supposed to be 2 over 1 plus 4x squared. All right, so what if I had the arc chord? Arc chord is very similar to arctan. Okay, arc chord, the arc chord of a particular function, that's supposed to be the negative of that of tan. Okay, just like the cos is the negative of that of arc sine, so arc chord is the negative of that of arc tan. So I should have f prime of x upon 1 plus the square of the particular function. So I should also have that of sec, the arc sec of x, the arc sec of x, the arc sec of x, or the arc sec of a function of x. That will be 1 over, or the derivative of that function, that is f prime of x. These formulas are the general formula that you can apply for any kind of function, so that you have x, or the particular function, that's f of x, then square root of the square of that function minus 1. Okay, the space, the square of the function minus 1. So cosec is the negative of this. The arc cosec of x is the negative of this. Just apply the negative and put the formula. Okay, so I hope that this video will really be helpful for you. So let me know if you have any complaint in the comment section. Okay, and let me know if you got the understanding. All right, thank you for watching this video. Share it with your friends.